Kia ora and welcome to video 22. You would not believe how many times I said 2022 in the recording of this. This is the home stretch for this series, the last week of videos for algebra. In the future or later this year, I'm looking at recording some other videos, maybe on calculus, but I'm happy to take suggestions. Just drop a comment down below, as they say in the YouTube game. Like, subscribe, and all that good stuff. So here is our problem. It's similar to the last video that I did, and that we're looking at the number of solutions for this equation. However, there's a square root in there, so just be careful with that, and I'll catch you on the flip side with the intro music. All the best. Okay, so unlike the problem in the last video, this equation here, having precisely two distinct real solutions, can be solved quite simply using the discriminant. Of course, we've got that extra complication, and there's a square root there, but I'm going to make a substitution to just simplify this. So if we go and let this whole thing here equal, what do we want it to equal? Actually, no, I'll make this thing here equal to u. So if I say let u equal 8x squared minus 32x minus 8c, then u divided by 8 is x squared minus 4x minus c, which is the thing that's in the front, the first three terms. So I've got a problem that simplifies down to u divided by 8 minus the square root of u equals 0. And if I rearrange this, square both sides, I've got a quadratic equation. With two possibilities for u. So we've got either u is equal to 0, which is solving this problem. We can divide the whole thing through by 8, of course, and apply the discriminant on that. And then think about the sign of the discriminant. Or we've got the other possibility for u. u is 64, and that comes down to, well, start off with what u actually was, and divide everything through by 8 again, and then rearrange it. We've just got that extra term in there, the minus 8. So the discriminant is similar but different. That's equal to 48 plus 4c. So we've got two discriminants. We want the whole problem to have exactly two solutions to it, and at the moment we've got two quadratics, both equaling 0, which could generate up to 4 solutions for the problem. So let's just have a quick look at Desmos before we solve this. I've put in the graph in red. There is the left hand side of the equation. I've taken the whole square root term to the other side and made it a different graph, and then I'm going to look at how many positions these graphs meet at. So what you should notice straight away is that they meet on the x-intercepts. That's because we just found that u is equal to 0 generated some solutions. And if I move c upwards and upwards and upwards, that always is true. So there's two solutions there. But if I decrease c, see how the red graph is moving up and up and up, but the blue graph always cuts the x-axis. And then boom, there's only one solution there. And now they're moving both up, and there are none. Sorry, my bad, there are two. We're looking at the points where the graphs meet. So if we back up a sec, actually that was 3. That's 4, because the intersection points at the top as well. Okay, so we've got a whole heap of scenarios, and it seems like our critical values are c equals minus 4, when that thing changes from 4 solutions to 3 solutions, and then to 2 solutions, and then the other critical value is c equals minus 12, which I'm not going to get there unless I change the lower limit. And that's when they are tangent, and it's one solution. Okay, so that gives us an idea of what we're expecting to see. Now, if I draw a number line, put in the minus 12 and the minus 4 as critical values, they're where the discriminants here equal to 0. So if I solve this discriminant equal to 0, I get c equals minus 4. If I just solve this discriminant equal to 0, I get c equals minus 12. And then we just need to consider either side of that. So anything that's less than minus 12, both discriminants will be negative, therefore no real solutions at all. So none, and then 1. If c is in between minus 12 and minus 4, one of the discriminants is negative, but the other one's positive, so 2. And then 3 here, and then if c is greater than minus 4, both the discriminants are positive, so we get 4 solutions. And so just exactly 2. For c values between minus 12 and minus 4. Now that's the answer, but there was some dodgy maths in there. I'm not going to lie. When I came up to this problem here, I squared both sides here willy-nilly. And when you square sides of an equation, if you think back to complex numbers, the external assessment for NCA students, when you square both sides of an equation, sometimes you can bring in an answer that isn't actually an answer. And if we've introduced an answer that actually wasn't an answer, then some of the work down below might have been wrong, even though we know it's not because we've seen the Desmos graph. So I'm just going to show you one of the questions from last year's complex numbers external as an aside here. I'm going to do the same sort of stuff. I'm going to rearrange the equation. So I've got x plus 5 equals 2 root x plus p. You might want to pause the video and give this a go. We're looking for one real solution to this problem. So squaring both sides is dodgy maths because it introduces potentially solutions that don't actually exist. Okay, we've got a standard quadratic here, just need to rearrange it. And then we apply the discriminant and we're looking for one real solution. So of course the discriminant just has to be equal to 0. Discriminant 36 minus 4 lots of 25 minus 4p equals 0. And if we solve that problem, we end up with p is equal to 4. And we go happy days, that's the answer. Now if you look at the NCA mark schedule for 2022, that's what they gave for a merit. In fact, that's actually the wrong answer. And the easy way of explaining why that's the wrong answer, or not sufficient an answer, is if I consider what this graph here looks like, y equals x plus 5, and then consider what this graph here looks like, y equals 2 square root of x plus p. Now, of course, x plus 5 is just a straight line, persisting without using Desmos here. And it's got a x-intercept of minus 5 and a y-intercept of positive 5. And then 2 square root x plus p. Well, it's a positive square root graph, and it depends on what p is. It's going to have an x-intercept of minus p. So, e.g. for our example here, when p is 4, it's going to have an x-intercept of minus 4. And it's going to look like that. If p equals 4, and it's tangent. But I only need to adjust p slightly for it to have no solutions, and that would be the case if p was less than 4. For example, another colour, I could have something that looks like this, and that would be, say, minus 3, if p equals 3, no solutions. But I could also have a case where the graph is on the other side, something like, oopsies, I wanted to change the color on that one, something like that. Now that only cuts at one position, it's not a tangent, but because the curve doesn't go below, and that's the key idea here, it stops at the x-axis because it's a positive square root graph. And when I square both sides of the equation, when I go from here to here, this is my effectively my y squared. I'm graphing y squared equals 4x plus p, and that there is a parabola that's sideways, and therefore it would cut twice. Okay, but the original equation, which had a square root in it, actually didn't intersect the line at two positions. So the complete answer to that problem would actually be needing a bit more work. Let's now go to Desmos and see how accurate my graphs were. So we've got y equals x plus 5, y equals square root, oops, here is it 2 square root x plus p. Okay. Right, and p is equal to 4, as we expected. When p is equal to 5, we get 2 because the square root is starting at the x-intercept of the line, but then if p is greater than 5, of course we've only got one solution. So the final answer to that problem should have been p is equal to 4 or p is greater than 5. And for me that's an excellent question, but I don't think NCEA expected students to pick up on that. Just be careful when you're squaring. Now I guess the question comes to, well, how come the squaring didn't cause a problem with this equation? And I'd like you to pause and think about that before I announce the answer to it. Okay, the reason is if we consider this equation as just two graphs where they're meeting. So we have y equals x squared minus 4x minus c, and we have y equals the square root of 8 times x squared minus 4x minus c. Well, they both have the same sign because they both share this common quantity, which means if y is positive, then, well, y has to be positive because it's a positive square root, but squaring it isn't introducing any new solutions to the problem. Whereas on this one, the right-hand side's always positive. 2 root x plus p is positive, but x plus 5 on the left-hand side could be positive or negative. So when we square it, we're introducing another case of solutions. Here, both, or the right-hand side is positive, the left-hand side is the same quantity, it has the same sign. So if the right-hand side's positive, the left-hand side has to be positive as well. We're not introducing other scenarios of solutions. Okay, hopefully you found those clarifications quite interesting and useful, and we'll catch you in the next video. Bye for now.